After the launch of Sputnik in 1957, which had a devastating impact on the morale of the West, the United States collected what seemed to be the final defeat on April 12, 1961, when Yuri Gagarin, 1934 to 1968, aboard Vostok 1, flew around the Earth for the first time. It was a huge media success for Soviet technology, and America was annihilated. But there was immediately a reaction. Just a week later, on April 20th, President John Kennedy, 1917 to 1963, wrote to his deputy, Lyndon Johnson, 1908 to 1973, who was also head of the National Aeronautics and Space Council at the time, asking him to identify a space endeavor that would restore pride and prestige to the country. Asked about it, the director of NASA's Space Flight Center, Wernher von Braun, 1912 to 1977, proposed to attempt the human exploration of the moon, a great feat that would take about a decade, so far enough in time to make up lost ground. Thus, on May 25, 1961, Kennedy announced to Congress the USA's firm intention to bring men to the moon in a short time. The result was a burst of pride for the nation, even if, according to the experts, the games were already done. The Soviet Union would also win the race to the moon, which then, as we all know, did not happen. And at this point, the question can only be, why? Why did the Russians lose the moon? The reason why the Russians, starting from an advantageous situation, lost almost without fighting the race to the moon is an argument long debated by historians. In the United States, the problem has been dismissed for decades with a very simplistic explanation. The Soviets could not compete with the superior American technology and had no hope even at the start. In reality, it seems that the reasons were multiple, at least 5 of great importance, and that among them, technological inferiority is only marginally included. The first reason was the total lack of organization. The idea that in the 60s the West had of the Soviet space program was that of a giant, perfectly oiled machine, all devoted to the success of the country and the party. And instead, it happened quite the opposite. The Soviet Union didn't even have a real space program, no multi-year forecasts, allocation of funds, or political direction. Projects were approved from time to time, unrelated to each other, and according to the media opportunity of the moment, often without even verifying their economic coverage. Under these conditions, success depended exclusively on the talent and merit of some engineers. Very often, the administrative directors were bureaucrats without the slightest technical preparation, who simply decided on promotions and punishments on political and radical grounds, or applied the directives coming from the party. In short, a complex project such as the flight to the moon would have required the joint and coordinated efforts of an entire nation. While in the Soviet Union, everyone went their own way, and often institutes, politicians, and the military put obstacles in each other's way, chasing only prestige and personal power. The second reason for the Soviet failure was the insufficient political and financial commitment. While the United States, since 1961, dedicated a substantial portion of the national budget to the space enterprise and involved some of the largest national industries: Boeing, Rockwell, McDonnell Douglas, IBM, General Electric, etc. In the USSR until 1964, the only top politician to show any interest in space was Nikita Khrushchev, 1894 to 1971. From the point of view of financial commitment, the gross domestic product of the United States in the 60s was about to double that of the Soviet Union. But according to some analysts, the expenditure that the US incurred for their space program was 5 times higher, an economic commitment completely unsustainable for the USSR, especially since Leonid Brezhnev, 1906 to 1982, contrary to his predecessor Khrushchev, believed that military and agricultural spending should take priority over space spending. From this point of view, it is clear that the cost of sending a man to the moon was badly balanced with the effort to equip himself with thousands of intercontinental missiles, an effort made at a time when agriculture was going through a particular crisis and the people were starving. Moreover, after the gauntlet launched by Kennedy in 1961, the Soviet government underestimated for a long time the positive media effects of a possible conquest of the moon and believed that the Americans would never be able to complete such an ambitious project. The idea of responding to the challenge of the Americans came only in 1963 to the big boss of the Soviet space program, Sergei Korolev, 1907 to 1966. But for a utilitarian and far from noble reason, the N-1 rocket he had designed was poorly financed and was accumulating years of delay. The lack of funds was in turn caused by the lack of political interest in the possible applications of the new launcher. So Korolev decided to invent a purpose that was politically attractive and attracted the necessary money. He proposed to Khrushchev and his ministers to respond to the American challenge, but for over a year his demands fell on deaf ears, mainly because of the exorbitant cost involved. Then in 1964, with the success of the Gemini missions and the first launches of the Saturn V, the Soviet leadership began to worry seriously about American progress, at least in words. In recent years, faced with the specter of the first defeat in space, the Russian government issued a series of provisions, threatening its officials with retaliation if the Americans arrived first on the moon. But the level of funding increased only marginally, and the deadlines were compressed beyond reasonable limits. Obviously, the project leaders, overburdened with ever-increasing workloads, instead of feeling spurred on by the government threats, lost all hope and began to blame each other. It is clear that such a short-sighted attitude on the part of the Russian government could only lead to failure. The third cause was the lack of leadership. As the complexity of the systems and the number of institutes involved increased, Korolev had to enlarge the design team from the initial number of 6 to over 20 components, which made it unmanageable. Every time Korolev tried to make the initiative and impose his will, his subordinates accused him of despotism, sometimes voting against him out of spite. With his progressive loss of power, Korolev's ambitious plans began to creak. The situation worsened by health problems, and then in 1966, his premature death. The position of head of the space program was thus taken by Vasily Mishin, 1917 to 2001, a person totally inadequate for that role. Mishin was a first-rate mathematician, an excellent engineer, and a brilliant inventor, but he did not have Korolev's managerial or human skills. On the contrary, he had a temperamental and undiplomatic character. He wasn't able to mediate and listen to the opinions of others, and often behaved embarrassingly. Sometimes he would explode into hysterical scenes because of trifles and refuse to obey the orders of his superiors, even those of the Council of Ministers, unless accompanied by technical justifications that would convince him. Once Khrushchev, speaking of him, said that he was a genius at calculating interplanetary trajectories, but had no idea how to deal with people. Cosmonauts also believed that he was a weak person and incapable of making important and risky decisions. Because of his way of doing, Mishin quickly lost the support of the cosmonauts and military leadership, plunging the Soviet space program into chaos at the very moment when the United States was supporting its maximum effort with the first Apollo tests. The fourth reason for the defeat was a series of wrong technical choices, one of the most important of which was the strategy of relying almost entirely on automatisms. It has often been said that the Russians could never have done something similar to the American project because they did not have an electronic industry advanced enough to realize the computers that Apollo capsules were equipped with. In the West, the Russian electronics was always considered rightly primitive and little developed. Yet the Russians, with the little they had, wanted to do amazing things. The system thought by the Americans was built around the 3 crewmen, who were the real computer of the Apollo. The machines took care of the routine tasks, but on board there were 3 pilots who knew the equipment in detail and could take the controls and cope with any eventuality. In addition, some complex maneuvers, such as docking between the spacecraft, were carried out completely manually after dozens of hours spent in the simulator. The choice involved a high initial risk, because the tests of the integrated systems could be done only in orbit with the men on board, and this was the reason of the 4 manned missions that were necessary before attempting the actual landing. But it was a choice that proved to be a winner in the long run, since in every single Apollo mission, there was at least one serious inconvenience that was promptly solved by the crew. On the other hand, the Russians insisted on developing almost completely automatic missions, with cosmonauts who were little more than passengers. This approach derived from a global technocratic ideology, according to which the real masters of any decision in space were scientists and engineers who wanted to have everything under their control, even if in fact someone else was going to space. This way of thinking led to frequent tensions with the staff of cosmonauts, who on one hand felt belittled and treated as laboratory guinea pigs, on the other hand saw their role threatened by the engineers' attempts to replace them even during orbital flights. Gagarin more than once in a sarcastic tone asked himself, "Who am I? The first man in space or the last dog?" If the automatic flight approach was feasible in the first Vostok orbital missions and had been successful, going to the moon was something tremendously more complex and probably outside the technological possibilities of the time. The choice of automatisms is even more surprising if you think that one of the biggest problems of Russian vehicles was always the weight, not having the same miniaturization capabilities of American industries. The Soviets did even more complex things, but with systems generally larger and heavier, usually compensating for the greater load with more powerful launchers. For example, the first Soyuz didn't have a real digital computer on board and couldn't perform the orbital calculations necessary to make the hooks between aircraft, but they succeeded anyway, using a complicated analog system based on successive attempts and approximations, called Igla Needle. The system, however, was rather unreliable, and in 1977, after some failures and misconnections, its designer Armen Natsakyanin, 1918 to 1992, was fired. The weight in particular was such a critical parameter that every kilogram could make the difference, so the desire to fill the inhabited ships with heavy electronics could lead to a dead end, as in fact happened. The choice of flight almost totally automatic, with cosmonauts acting only as backups in case of failure, also led to the development of navigation and docking systems that were much more complex and had a very low flexibility. In fact, since it was not possible to have computers on board to perform all the calculations in real time, the orbits and operations were pre-calculated by the scientists on the ground and entered into the systems just before departure. This resulted in extremely narrow launch windows and the risk of having to abort the trip at the first slightest inconvenience. In addition, development time expanded enormously, and as we will see, there were many unmanned missions that failed in their attempt to fine-tune the systems. The fifth reason, finally, is a bit of bad luck, mixed with managerial naivety. The launchers developed by the Soviets for the lunar missions, the Proton and the N-1, went through many problems and failures before reaching an adequate level of reliability. The Proton failed 13 of the first 19 launches with lunar spacecraft on board, while the N-1 never successfully completed any takeoff. But this is a path of refinement that almost all the rockets of that time went through. The qualification process of a ballistic missile could require up to 100 launches. After all, even the Vectors developed in the 1990s, with the support of sophisticated computer simulators, often failed the inaugural takeoff. The American Saturn V was a lucky exception. It worked perfectly from the beginning, and in its 13 launches, never missed a shot. Almost a miracle. To give credit where credit is due, however, it should not be forgotten that the reliability of the American vehicles was achieved with a very accurate system of controls and checks put in place at every stage of production and integration. This system today is a standard in the space industry, but the Russians neglected it and discovered it almost 20 years later, after losing an endless series of rockets, probes, shuttles, and space stations for even trivial failures. Evaluating rivals with their own meter was another fundamental mistake of the leaders of the Soviet space program. In 1967 and 68, when the flights of the Apollo missions began, the Russians did not expect at all that within a few months NASA would be able to land a man on the moon. Still, in the spring of 1969, they were convinced that the real lunar mission would have happened in 70 or 71, which would have left them the possibility to recover the lost time. In the Soviet experience, before having a working vehicle, it was necessary to launch dozens of prototypes and fail as many missions because the culture of ground testing simply did not exist. In the United States, on the other hand, when the first Apollo shuttles took off, the systems had already been verified and tested for years, and it was only necessary to accomplish the final mission. After 1969, the Soviets tried again for a year or two to chase the United States, but soon became aware that the race was lost, and there would be no payback.